5.4. First thing we're going to talk about is a rhombus. And by definition, a rhombus is a quadrilateral with 4 congruent sides. That means all the sides are the same. All 4 sides are the same. By definition, that is a rhombus. So any figure that has 4 congruent sides is a rhombus. Okay. And we know a rhombus is a type of parallelogram. So because it is a type of parallelogram, all those properties apply to a rhombus as well. So what do we know about the opposite sides of a parallelogram? They are parallel. So that side and that side are parallel to each other, and those 2 sides are parallel. Always true for parallelograms, so it's going to be true for a rhombus. We also know the opposite sides are parallel and they are congruent. Yeah.
Things you know about these things.
They're congruent. Well, all 4 sides are congruent, so that's going to be the same.
Okay, mark your diagram. So you have this for reference.
What do we know about the opposite angles of a parallelogram? Well, they're also congruent. So A is congruent to C, and D is congruent to B. That's also true for a rhombus because it's a parallelogram. What do we notice about the angles next to each other in a parallelogram? They equal 90, yeah. So, for example, you would say the measure of angle A plus the measure of angle B equals 180. Angles next to each other are still supplementary. What do we know about the diagonals of a parallelogram? What do they do to each other? They bisect each other. Cut each other in half. So we know that this piece and this piece are the same, and those 2 pieces are the same. And all those important properties of parallelograms also apply to a rhombus. There are some new things that only apply to a rhombus and a rhombus only. It doesn't apply to a rectangle, doesn't apply to every parallelogram, only applies to a rhombus. Okay? By definition, what we just talked about, 4 congruent sides. The diagonals are perpendicular. Remember that upside down T means perpendicular? Well, what kind of angles are formed at perpendicular lines? Right angles. So that means these inside angles with the diagonals in a rhombus are all 90 degrees. All those inside angles are 90 degrees with the diagonal. And only a rhombus. Not a rectangle, not an everyday parallelogram, only a rhombus. Okay. The diagonals also bisect the opposite angle. So these diagonals are cutting these big angles in half. So this little angle is congruent to this little angle. You could say, for example, the measure of angle ADB is congruent to the measure of angle BDC. Those 2 little angles are the same. So this angle, and this angle are the same. Okay? This angle and this angle are the same. This one and this one, this one and that. All those little angles next to each other are the same. So their diagonals are cutting them in half. Okay? Questions on that? Now, only those bottom 3 only work for a rhombus. Not a rectangle, not a parallelogram, just a rhombus.
Rhombus, a lot of cool things with those rhombi. So let's flip it over. Oh, you guys have scrolled down. Let's try these out in real time here. So I've got a rhombus, ABCD. AB is that, BC is that. Find X, find AD. All right, let's go ahead here. Well, what do you notice about my picture right now? Got the issue going on.
Where's X?
Well, where's X? That's what we're finding, but what is going on with my diagram? Any questions? Any issues with this? Issues? Yes, you. It's not labeled. So we should always label it. A lot of you guys try to do it without labeling it, and you might set it up incorrectly. Let's go ahead and label it. AB is up here, and I know that is 2x plus 3. BC is over here. This is 5x. Oh, no. How does that help me out? Normally, I would say these are sides, which they are, and I know that opposite sides are congruent, but they're not opposite of each other. Emmett, you have an idea? All four sides are congruent, exactly right. So I can say that side's congruent to that side. That side's congruent to that side. Now what can I do to set these up? Set them equal, because they are equal. So I'm going to say 2x plus 3 is equal to 5x. Very good. And again, we go ahead and solve. What do you want to do to solve this? Subtract what? Do it to subtract 2x. A great idea. I like to move the smaller of the x's myself as well. Minus 2x, minus 2x. He gone. 3 equals 5 minus 2. 3x. Well, let's do this point. Divided 5 by 3, divided 5 by 3. He gone. So x is equal to 1. Uno. Nice. So I know x is equal to 1. Awesome. Now it says to find what AD is. So we are looking for the athletic director. That side right there. There's nothing there. How do I find it? Can't do. Jake, you got an idea?
So if BC is right across from it,
Okay.
they're both equal.
They're both, I agree. You're saying that's equal to that. Good. So how's that going to help me?
5x. 5.
Oh, so you're saying take this value, plug it in right there since all the sides are the same, and I can just do 5 times 1 would give me my answer? Get our calculators. 5 times 1. You need a calculator for that one, because anything times 1 is itself. So guess what? It is 5, so therefore AD is equal to 5. Done. All right. Questions on that? Sides congruent, all 4 of them. Moving on, this guy. Well, still dealing with a rhombus, or a rhombi. So, again, I think we had that same issue with that labeling situation. Find y if the measure of angle 3 is y squared minus 31. Okay. Well, where's angle 3 at? Where's angle 3 on the diagram? Not up there? Doesn't exist? It's where? In the middle. Great idea. I'll say that. So angle 3 is right here. So I can't really write that in there, so I'm going to draw a little line above it. And I know that that measure is y squared minus 31. There's nothing else. I don't have another side on another angle. So what do? Colby. What? How'd you know that? I don't have any little squares up there. Oh, diagonals are perpendicular to rhombus, therefore they make 90-degree angles. So really, I shouldn't draw this as a little arc. I should draw this as the box right there, 90-degree angle box. So I know that's 90 degrees, but not only that, it is also y squared minus 31. So they are equal. So I'm going to go ahead and set them equal and say that y squared minus 31 is equal to 90. And again, just like before, it's that bare problem. We're ultimately solving for y. What's my next step in the process? Add 31. I tend to agree. Here you go. Y squared equals... David, thanks for calculating this. Yeah? Oh, no, he didn't calculate it. Oh, now he calculated it. 121, good. How do I get rid of that square? Square. What undoes a square, Derek? Square root. Square root, the root's on fire. So y equals, what is the square root of 121? It's going to be a huge number. It is what? 11. Okay, are we done? Are we done? Can I move on to the next problem? Aaron, am I done? You sure? She's shaking her head yes. Have that on record over here, microphone. She's shaking her head yes. We are done because it says fine. Why? Found it. There it is. Okay. Diagonals are perpendicular. They make 90-degree angles. Moving on to number 3. You guys ready to move on? You guys are taking this in stride. Good job. Number B. So the measure of RST is 56. The measure of angle 1, the measure of angle 2. Oh, we want to find those, excuse me. And measure of TQS. 3 things? It's unheard of. I'm going to find 3 pieces. Well, first thing first, let's make sure I label my diagram. The measure of RST is 56. I'm going to go with my highlighter, just see where that angle's at. So, do a nice blue. RST, right there. That angle right there. I know that measure is 56 degrees. I need to find angle 1 and 2, those 2 dudes up there at the top, and TQS. TQS, we'll find the other one in a second. Huh. Who has an idea of how to figure out 1 and 2? Shane, what's your plan? I like what you're saying here. But the problem is that if I did that, he's saying take 56 divided by 2 to find that little angle, each of those, because they are bisected. That is 100% correct. But how would I figure out that one if I only had 2? I wouldn't be able to subtract anything. Okay, that wouldn't be enough though, because that'd only be 2 angles if I did that. You need that third angle. You want to do it that way. You're on the right track. You're very close on this. If you knew that other angle, we could do that. Yes? That would tell me what this little angle is right here. That would tell me what this angle is, and that's what Shane's kind of saying, and that angle is. And we can't do that. But we're looking for these guys up here. Not the same. Jason.
Wouldn't 36 be equal to 1 because
They're
like 2 bow tie triangles put together?
Oh, I see what you're saying. Yeah, if we do this, there are some bow ties up here, depending on how you're looking at it. But this is 56 is the whole angle over here. We're trying to find this angle up there.
You cut 56 in half.
I can, and that will give me that. That's what everyone's saying there. I'm trying to look up here, though. Yes, Alexia. Yes, okay, that's fine. Let's write that down. So this angle right there is 28, as well as that one. TQR, so you're looking, all right, you're going angle on me. All right, TQR. Okay, so those are both 28 and 28. I agree, because we know opposite angles are congruent. We have bisectors, okay. So you do 180 minus 28.
Right.
You guys are on our track. We want to be over here. You guys are correct. Those are both 28. I agree. What do I know about angles that are side by side? Oh, yes. Yes, because I know angles that are side by side. This angle, and let's say this angle. Are what? What do we call angles that are side by side? They are, oh, not corresponding. Corresponding to the same corner. They are what? Supplementary. Supplementary adds up to? So 180. If I know this is 56, I'll subtract 180 and figure out what that angle is. So I'm going to do 180 minus 56. Maybe. What's 180 minus 56? 124. So I know this whole angle over here is 124. That's what that blue line is. I want to figure out what 1 and 2 are. So how do I figure out what angle 1 and angle 2 are? You guys have already been doing it 25,000 different ways on the other 2 angles. Derek, what do I need to do? Yeah, cut it in half. I know it's an angle bisector, so I'm going to divide by 2. So I'm going to do 124 divided by 2, and that will give me what each of those angles are. Half of 124 gives me a 62. There you are, Waterboy. I don't remember Waterboy. Too bad. So now I can say that the measure of angle 1 is equal to 62, as well as the measure of angle 2 is also 62. They're also 62 degrees. Great. And since that you guys kept trying your hardest to keep figuring out that 28, 28, those are correct. But now we're looking at the last part of the question. It says, I want to know what TQS is. TQS. You already pieced it together. So what is the measure of angle TQS? 28. Don't overthink, it's right there. You knew that opposite angles are congruent. So that's 56, that's 56. We also know that the diagonals bisect. So that's 56 cut in half, they're exactly the same. They do create isosceles triangles. I don't know if Jason was hitting on this, but they do make isosceles triangles in this. And we know that because all the sides are going to be congruent as well. So really it has to be two isosceles triangles back to back like that. So I do know that the measure of angle TQS is 28 degrees. Love pieces. Multiple ways to solve these. Somebody from an earlier class was saying that these are rhombuses, rhombi. So I know that there's 90-degree angles in the middle. And some of you guys were on the right track, you didn't finish it off. And I say, all right, that makes a right triangle right there. If I know this is 28 degrees, I know this is 98 degrees. Can I add those two together and subtract from 180 to figure out 60? You did not say that. You didn't say the 90 in there. No. No. We're right. But there's another way of solving it. If you did say it, I apologize. But for the record, she did not say that microphone. Okay? Questions? Whoa, 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 whoa. I know you were going. We have one more.
Good thing we have the microphone on. We can go rewatch it.
You can relive it. That's true.
Yeah.
But it won't pick you up, so too bad. The last one is the hybrid. It's like the Liger of math.
Okay. A square, by definition, is a quadrilateral with 4 congruent sides and 4 congruent angles, which are all right angles. Okay. Well, what other figures have 4 right angles? Talked about it yesterday. Rectangles. Rectangles, by definition, if you have 4 right angles, you're a rectangle. What did we just talk about if we had 4 congruent sides? You're a what? Rhombus. So by definition, a square is a type of rectangle, because it has 4 right angles. It's a type of rhombus, because it has 4 congruent sides. And because it's a rectangle, because it's a rhombus, it's also a parallelogram. It's all 3.
Hybrid. Scroll in there.
Okay. All 3. It's a rectangle, it's a rhombus, and it's a parallelogram. So all properties for all 3 of those things apply to a square. You can't go wrong with a square. Everything works with a square. Okay, so we said all the angles are right angles. I'm going to mark that. 90, 90, 90, 90. We said all the sides are congruent. So I'm going to mark that. What else do we know? We know it's a parallelogram. What do we know about the opposite sides? They're also, we know they're congruent. They're also what? Parallel. The opposite sides are parallel in the square. What do we know about the opposite angles? They're congruent. They're both 90. What do we know about the angles next to each other? They add 180. 90 plus 90 is 180. That's still true in a square. What do we know about the diagonals? What do they do to each other? It's a parallelogram. They bisect each other. So this guy's bisecting this one, and those two are bisecting. Well,
I thought it was squares they were on.
yeah, because it's a rectangle. What did we talk about the diagonals of a rectangle? They're all what? Equal. So the diagonals in a square are also going to be equal, which means if these cutting each other in half, then all those little pieces are also going to be the same in a square. Okay. What else do we know about the diagonals of a square? What did we just learn about a rhombus? What kind of angles are formed? 90. So these are all 90-degree angles. So in the middle, just like a rhombus, those angles on the inside are 90 degrees. What do we know about the diagonals? What are they doing to these angles? Same thing as a rhombus. What are the diagonals doing to the angles? They're bisecting them, and it's nice because it's a square. We know the measures of these angles are 90 degrees. So if you cut 90 degrees in half, what do you get? 45. So we know all these little angles right here are 45 degrees because those diagonals are cutting them in half. So we know they're 45. Well, all four of these triangles, if this is a right angle, are what type of triangles? 45, 45, 90. So in a square, those little triangles formed by the diagonals are all going to be 45, 45, 90 right triangles. Alright? So every single property of a parallelogram or rectangle and a rhombus applies to a square. Everything works with a square.
Great.
Questions over that?